Welcome, everybody, to another episode. All right, so we're talking about trigonometry 8.4 here. So, just a couple of things about trigonometry. Again, it's more exactly, it's measures of triangles, but more specifically, the relation between angles and the sides of the triangle. Now, this whole idea was done back in the Greeks. Hippocrates was known as the father of Greece. He created this table, which is a very long, extensive table, which if you Google a trigonometry table, you'll see it. But let's talk about tangent. Tangent is our first ratio we're going to talk about. So when we're talking about ratios, it's when we talk about ratios at the beginning of chapter 7, we're talking about comparing numbers. So this over this to this, so on and so forth. Well, trigonometry ratios are just that. It's comparing two things, but to with a certain little extra flair. In this case, we're doing a tangent ratio. So let's look at a tangent ratio. Now, the way tangent ratios work is you have some angle, a reference angle. We call it theta. Now, theta is a Greek letter. That's what we usually use to represent the angle. That's the placeholder. You can also have A's, B's, C's, D's, Y's, X, and B's. Different things. But now, once you have an angle established as your reference angle, from there, you name your side. So the side across from that, your reference angle, is known as just that, the opposite side. The hypotenuse is always across the 90-degree angle, so that's our hypotenuse. And the adjacent is the side that's next to the angle, not the hypotenuse. Now, as the tangent ratio is stated, the tangent of an angle equals to the opposite side length over the adjacent side length. So let's kind of test that out. So we're going to start with this triangle as an example. So they're telling us this angle is 30, so this is our reference angle right here. So theta. So that being said, this side x will be considered our opposite side. And the 5 radical 3 will be our adjacent side. And of course, here's a 90-degree angle. This is our hypotenuse. We don't use hypotenuse in this case because there's nothing there to use. But to solve for, we use sine, cosine, tangent specifically right now to solve for a missing side. So let's try that. So if we're going to set up our tangent ratio, we say the tangent of the angle, so tangent of 30 degrees, equals our opposite side, x, over our adjacent side, which is 5 radical 3. So just like any other problem, math problem, when you're solving for an unknown, we try to get that unknown by ourselves. So we're going to try to get this x by itself by multiplying both sides by 5 radical 3. When doing so, we're left with 5 radical 3 times the tangent of 30 equals x, equals our value that we are looking for. Let me get a calculator. So from there, we're going to put that in the calculator. Now, you guys, again, if you have a calculator, a legit calculator, you should be able to plug that in just as it is. So you hit 5 radical 3. Now make sure you exit out of your radical. Sometimes that was a problem that we had as we were doing in class. And then times the tangent of 30 degrees. Plug it all at once. You should get the value of 5. So all this equals 5. Now, I picked this specific problem because this is also a special right triangle at 30, 60, 90, where the smallest side is to go from the small side to the long side, you multiply by radical 3. So to go backwards, you divide by radical 3. That's why that is 5. But I wanted it so you know that this is what you should get as an answer. Now, you guys who have an iPhones or some of the smaller calculator that's less than the TI-30, you might have to put it in backwards. So sometimes you have to put it in backwards. So on an iPhone user, you hit 30, hit that first, and then you just hit the button tangent. It gives you a decimal number. And they hit times, and then you do 3, and they hit the square root button, which is the 2 with the radical x on the inside, and then times 5. And that should give you your answer of 5. All right. So let's look at this next problem over here, this bottom one down here. I'm going to erase what's on the screen right now. So this time, we're going to use angle 58 as our reference angle because we're going to have this in the denominator. So in case you run into a problem where you're unknowns in the denominator, we should be able to figure that out. So let's kind of set it up. So from here, 22 is not considered our opposite side, and x is considered our adjacent side. Side note real quick, if this was our theta, if this was the angle we're using, this will be considered the opposite, and this will be considered the adjacent. So always remember, adjacent and opposite switch depending on which angle you are using. Hypotenuse stays as hypotenuse regardless. But we're using this 58, so we're going to set it up as tangent of 58 equals our opposite side, 22, over our adjacent side, x. All right, so the issue here is, one, we got to get x by itself, but the other part is x is in the denominator, and we cannot have that in the denominator. So to solve that, we're going to multiply both sides by x. In doing so, it cancels out from one side, leaving us x times tangent of 58 equals 22. So now that we have x up in the numerator, we need to get rid of this tangent of 58. So this is x times tangent of 58. So we are going to divide both sides by tangent of 58. That reduces to cancel each other out, leaving us just x. And in the calculator, this is what you'll be putting, 22 over tangent 58 equals. So let's plug that in. So 22 divided by the tangent 58 gives us 13.747. So x rounds out to be 13.747. That's the value of this side right here. Now let's look at this one right here, tangent of 41, not 40p, 41. So when I ask you, hey, what's the tangent of this value right here? You literally just plug that in the calculator. So in the calculator, you hit tangent, then 41, close your parentheses, hit enter. You should get 0.869. And if you're trying to do it on your phone, you'll hit 41 and then hit tangent. That should give you the same answer. Now, if you have not gotten the same answer when you did your trig functions on your computer, on your calculator, make sure your calculator is not what we call in radian mode. Sometimes the RAD could throw that off, so we got to switch that out. Now let's look at our last problem. Now, sometimes, again, these tangent ratios are a relation of sides to angles. Sometimes we have to find the angle. So for example, in this problem, we're looking for y. Now we don't have y, but we do have two sides. We have the opposite side and the adjacent side. So we for sure be using some form of tangent. So let's set up our problem. Let's just set it up if we're looking for anything. So we say tangent of angle y equals 3/4. Now, if this was any other problem, if I wanted to get rid of the tangent with y, I would divide by tangent. But unlike anything else in math, you can't divide by a tangent. So you will multiply what's called its inverse. We call it inverse tangent or arc tangent sometimes. We multiply the inverse, so it's tangent to the -1 power. And you do so as well over here, tangent to the -1 power. When you do this, this cancels out the normal tangent, giving you just the value of the angle y degrees. But that means on the other side, this is what we're going to put in the calculator, inverse tangent of 3/4. So you guys with your calculators, your physical calculators, if you were to look where your sine, cosine, tangent is, right above those buttons, you see sine to -1, cosine to -1, tangent to the -1. Those are what we call our inverse tangents. So to access those numbers, I'll hit second and then tangent. It should pop out tangent to the -1 and then put 3 divided by 4 in the calculator, in the parentheses. Hit enter. You end up getting y to equal roughly 36.870. It rounds out. It was 8698. So we rounded it off to 36.870 degrees. All right. So that's just tangent ratio. Now we say that we teach that differently because it uses the legs. The other two, sine and cosine ratios, they use the hypotenuse. So this is your two other tangent ratios that we'll be using in this chapter, specifically more in this section. We got our sine of theta. So again, you have your right triangle, you have your reference angle, the angle that we will be using. So from there, you establish what's opposite, what's adjacent, and what's hypotenuse. So that is, for sine, we use the opposite side over the hypotenuse. And for cosine, we use the adjacent side over the hypotenuse. So another way to kind of remember which part goes what, and it gets pretty mind-boggling trying to keep all this in, but remember there's a saying SOHCAHTOA, SOHCAHTOA. So it kind of has a reference here. So sine is opposite over hypotenuse, cosine is adjacent to hypotenuse, and tangent is opposite over adjacent. Another way to kind of remember this is the little saying, some old hippie caught another hippie tripping on acid. So again, some sine old hippie caught cosine another hippie tripping tangent on acid. Kind of puts them all in order as what part goes with what. So let's kind of work these out right here. Let's try them out. So let's look at our examples. So on here, we are looking for this x. Now, it doesn't matter which one you pick, but I'm going to go with this 40 just because it's down here. So this is our reference angle. This is our theta. So this means this is our opposite side, making x our adjacent side. And of course, 12 is our hypotenuse. So we're going to set this up. Again, since we are looking, so again, our SOHCAHTOA. We are looking for the adjacent and we have the hypotenuse. And which of these uses adjacent and hypotenuse? Cosine. Cosine uses adjacent and hypotenuse. So when we set this up, we'll set it up as cosine of 40 degrees equals our adjacent over our hypotenuse, 12. And just like before, we're solving for x. So we'll multiply both sides by 12, giving us 12 times cosine of 40 equals x. And very similar to tangent, this is where we plug in the calculator. So we'll take 12 times, click on cosine, and then enter 40 in the parentheses, close your parentheses, hit enter. You should get roughly 9.193. Rounds out to make x. Now let's look at this next problem over here on this side. We have two unknowns. We have our x and our y, 37 being our reference angle. So that's our reference angle right here. And then makes x to be our opposite side and y to be our adjacent side. So let's set up solve for x first. So from theta, this is opposite. And of course, we know our hypotenuse. Which one uses opposite and hypotenuse over here? Sine. Sine uses opposite and hypotenuse. So we'll set it up as the sine of 37 equals our opposite, x, over our hypotenuse, 35. So then from here, just like before, to solve for x, we'll multiply both sides by the denominator to get rid of the denominator, 35, giving us just x on one side, and this side you should have 35 times the sine of 37. So in your calculator, you'll plug it in as 35 times the sine of 37 in the parentheses. You hit enter. Sorry, 35 times the sine of 37. You should get 21.06. We're going to round that up to 4. That's the value of our x. Let's look at our y. So our y, since that's the adjacent, and again, we have the hypotenuse, we're going to use cosine, which is adjacent and hypotenuse. So as we set this up, we'll have the cosine. Let me erase this stuff right here. Again, opposite, adjacent, hypotenuse. We're looking for the adjacent. We have the hypotenuse. That is cosine. That's our cos. So cosine of our reference angle 37 equals our adjacent side, y, over our hypotenuse, 35. So to solve for y, we'll multiply both sides by 35, giving us 35 times the cosine of 37 equals y. So this is what we put in the calculator right there. So 35 times the cosine of 37 degrees gives us 27.952 equals y. All right, so just like inverse tangent, we also have an inverse sine and an inverse cosine. So anytime our formula is given in this form or the form that we're used to, sine of some angle equals opposite over hypotenuse. To find the value of our hypotenuse, we have to get rid of the sine. So to do so, we multiply both sides by inverse sine. So that leaves us with, hey, theta degrees, so our theta equals the inverse sine of the opposite over the hypotenuse. So they're the same concept is with cosine and tangent cosine. So theta equals the inverse cosine of adjacent over hypotenuse. Again, these are the parts that cosine will use, so these are the same parts that inverse cosine will use. And for tangent, inverse tangent, for theta with the tangent, that is opposite over adjacent. So let's try that out. So for example here, we want to know what the value of angle A is. This is our theta right here. So if that's our theta, that makes this our opposite, this our adjacent. If this is our opposite adjacent, which of these three trig functions uses that? So sine, cosine, tangent. So which one uses opposite and adjacent? Tangent. So as we set this up, since we're looking for theta, we have theta equals, excuse me, inverse tangent, so tangent to the -1, of the opposite over the adjacent. This is what goes in the calculator just like that. So again, to access those inverse coordinate tabs, you hit the second button, then tangent, should bring up tangent to the -1, and then 6 divided by 20 inside the parentheses. You should get roughly theta to equal, theta degrees equals 16.699 degrees. So in this problem, we're going to find both B and A. So I'm going to put A in blue because that's going to be a different idea. We'll see why we'll do that. Let's start with B first. So to find B, then we'll make our opposite side will be 3. And this is, of course, the hypotenuse. So we don't have an adjacent from angle B. There's no side adjacent to angle B with the value, at least for now. So then, which trig function uses opposite and hypotenuse? Sine. So since we're doing the inverse sine, we'll do theta equals inverse sine of the opposite side, 3, over the adjacent side, 15. This is what's going to go in the calculator, just as is written right there. So inverse sine of 3 divided by 15 gives us theta to equal 11.537 degrees. All right, so let's look at trying to find angle A. So this time, this is our reference angle. So that 3 is no longer our opposite side. That is now our adjacent side. Our hypotenuse is still hypotenuse, regardless. And this time, we don't have an opposite value from A in this case. So which trig function uses adjacent and hypotenuse? It's our cosine. So since we are doing inverse, we're doing theta equals the inverse cosine of our adjacent side, 3, over our hypotenuse, 15. This is what goes in the calculator. So we'll hit second cosine to get that inverse trig function, and then 3 divided by 15. You get theta to equal 78.463. Hope this helps all you guys are gone, or you guys need to refer back to this. Y'all have a wonderful day.